Hey, hello YouTube. Welcome to my channel again. Today, let's look at leetcode2542 maximum subsequence score. Here is the problem description. So we're given a two array, nums1 and nums2. Each has some number here. And then we give another integer value k. We need to do this kind of a calculation. Uh, the summation from the nums1 and the minimum value from nums2 and to return the maximum value. So when I first look at this problem, I was actually go towards a brute force solution, and it was really not very performance effective. And then I spent some time and look at the other people's video, and then I realized that okay, greedy algorithm is the solution here. So in this particular video, my point is that I want to give another try to explain why greedy algorithm works here. Hopefully, this will help other people to understand the whole thing. Okay, without overdue, let's jump to the content. Okay, now let's look at how the greedy algorithm works. So the first step is to construct some data structure that will make our life easier. So the first thing to do is to construct things like this. So we're using the nums2 and nums1. And nums2 will behave like a key, and nums1 will behave like a value. We put them together so they are associated to each other. So that will give us the relation that we want to do the future calculation. And then what we need to do is to do the sorting. We actually sort it in a descending order, like you see here. And then this is actually will give is very handy for us, and this is actually the whole reason why greedy algorithm works here. So let me explain. Um, uh, let's look at this formula first, right? So here, the formula, basically the formula says is that we want to have first the summation, and then after we sum them up, then we want to have the minimum value from nums2 and to do the multiplication, right? So uh, the minimum value, if we have this descending order, and assume if 3 here is the minimum value, what does this tell us? This basically says that all the other value in nums2 that appear here is already we have already seen it. It must be on the left hand side of 3 because because the descending order guarantee that all the number that is bigger than 3 will be here. So that actually make us our life much easier is that when we calculate the summation and the minimum, when the descending order will guarantee us the key value here, it is equal to the minimum. That's the key value here. And then the summation, if we want to calculate that one, we only need to calculate the, the maximum k value summation, which we have seen already from here, right? So it's always on the left-hand side. All the value in this shaded area, which we are about to see, is not relevant to us because these are minimum requirements. If 2 for sure will not appear because 2 is smaller than 3. If 3 is the minimum value, then 2 is guaranteed won't appear. So no matter how big the value 2 corresponding to, it can be 1 million, but still this doesn't relevant to our summation calculation because of this one. Of course, when we come to 2, then the corresponding value will be associated, and then of course we need to compare with our previous calculated one. But for each of the iteration, we only need to care about the value that we have seen already, and using that to calculate the summation from nums1. And then for this minimum value, we only need to worry about the current value. So this actually reduces a lot of work from us, and that actually gave us a very quick solution. So that's why greedy algorithm works here, because we don't have to look at the global. We can just look at the local value we have seen here, and pick up the maximum, and that's the reason why it's called greedy. Always pick up the maximum, and then here pick up the minimum. Then you have the value you want to get for this iteration, and then as we progress, we will keep on maintaining this minimum heap. If it's more than k, we need to take away the first minimum value, because the minimum heap here will guarantee that the first value here is the smallest one, and the rest of these three will be for sure much bigger than that, because that's the minimum heap. So if we are adding a new value here, it's safe to remove these and then keep the heap in size of k. So with this knowledge, then we can actually keep on progressing until we reach the end. And for each of the iteration, we simply need to have a variable to memorize the maximum value we have seen so far and compare with the current calculation from here. So if the maximum value we have so far is smaller than the new value, then we update it. So that's the whole flow. And by traversing this array only in one time, we will get the maximum value we want. Okay, now we know how the greedy algorithm works. Let's look at the implementation. So the first line here is meant to construct this one. We put numbers 2 here first because that's the key. And then we want to sort it based on the key, use this sorted function. After that, we will have the structure look like this. So then we create a heap. The, the, the heap will be used to save the maximum k value from this numbers 1. And then we will start to go through the indexed nums, and we put all the number into this heap first, and we accumulate the numbers into that one. So this operation is actually corresponding to this, because here is a summation, and we actually calculate the summation as we progress. And when the length of the heap is bigger than k, that means inside the heap we already have a k plus 1 elements. We have to remove the head, so this is actually corresponding to this one. So this line is basically doing this. It takes away the minimum value from the heap, and then after that we will have this again this k elements. Then if the length of the heap is back to k, then we are ready to calculate the score. Right? So this accumulated value, this one is actually corresponding to these as we calculated, and this number 2, that's the key, and this key is actually corresponding to this smallest value in numbers 2. So this gave us the value we want to calculate based on this formula. After we have that, we need to compare with the previous max score, and if we are bigger, then we just reassign this maximum score, and until we finish the whole loop and then return the max score value. So this is the whole code. Okay, that's it for today. Thank you for watching, and see you next time.